And y'all can memorize it from here, but sine x starts at 0, goes up to 1, back to 0. That's your basic sine x graph. So I want you to graph that right now in pencil. We're only going to use our color for our final graph on each problem, okay? So graph that. You're going to have to memorize that.
Can we write it on our formula sheet?
I don't care. You don't have to.
Well, I'm saying, like, if it's going to be on the test.
We're going to do it for a week. You won't have any problem with that.
Well, I'm going to write it down.
Go ahead. All right, so let's go over it again. It starts at 0, it goes up to 1, back to 0, down 1, back to 0. So on 0, 3 places. All right, now this thing, guys, it goes forever. All right, a sine wave runs forever. Y'all did sine waves in what, like physical science or something. We're only showing, like if we kept going, it would look the same on the left and the right. We're only showing 1 pi. Because, Jacob, if I keep going, it's just going to start over and do the same thing it's been doing. So, the period for this graph is 2 pi. What does that mean? That's how far it has to go before it starts over. Then it would keep going. Does that make sense, Matthew? Let me say it again. All right, well, I'll tell you what, before I say it again, let's find our 4 answers for our new problem. It's already written down on your paper. All right, what's our amplitude going to be for this one? 3? Everybody understand it's 3, period. There's a 1 there. 2 pi over 1 is 2 pi. Why is there not a phase shift? No phase shift because there's no parentheses. Location change is not 1. All right, so this is what I'm talking about. The period is from here to here. Because look, if I kept going, Matthew, it would just start over and keep going all the way out here. So that's how far it has to go before it starts over, is the period. Does that make sense? It's like the length of it before it starts over. All right, so now the only adjustment we have to make on this problem, let me get me a few more lines up here. All right, now you guys need to get out your color. Everybody should have a color pencil. If not, I will bring you one. All right, look, guys, we don't have to change anything for the location change. There's not 1. There's not a phase shift. Period on our original was at 2 pi. Look, it stayed 2 pi. I don't have to change that. The only thing on this problem we have to change is the amplitude. All right, and watch me do this. Amplitude. Y'all see these 3 points on the x-axis? Amplitude, they will always stay the same. Go ahead and redraw those in your color. If it's on the x-axis, which is at 0, it will never change. All right, now let me explain amplitude to you. Matthew, they got a 3 in front of our new problem, right? All that means is, you see where I went up 1? If you multiply 1 times 3, you're now going to go up 3. So 1, 2, 3, and right here where I went down 1, I'm now going to go down 3. That is our new graph. That is what amplitude does. It just makes it wider, higher. That's probably a better word. Stretches it. So that's what you draw in your color, and we're done with number 1. So number 1, the only thing we had to change was the amplitude. Everything else stayed the same. Anybody have a question? You're going to have some questions, and that's okay. We'll do this for a long time before I give you a test on it. All right, can we go to number 2? I'll tell you what, let's go to number 3. The reason is, number 3 is sine x just like number 1 is sine x. So let's go to number 3. All right, and first thing I want you to do again is draw that sine x graph, that basic graph that you're going to have to memorize anyway. Curvy. Can we say it looks like a snake? Nah, would that help you memorize it? Draw your sine x graph. We're going to draw the parent graph on every problem first, and then we'll see if we got to change it. And you will always have to change it. All right, so now let's find our 4 answers for our new problem. You should have room right there on your paper to write them, correct? All right, so what's the amplitude going to be? Stay in 1, period. Well, there's a 1 there, right? So it's 2 pi over k, so it's just 2 pi. Phase shift. Now this one does have a phase shift because it's got parentheses. You guys remember how to do phase shift? This goes on top, but you got to flip the sign and divide it by 1. That's what we were doing on the chart. So what's our phase shift going to be? Positive pi, and there's no location change. So this is why we've been learning how to fill in the chart so we can learn how to graph.
So you have to basically work that out.
Yep, so amplitude didn't change, period didn't change, location change didn't change. The only thing I'm changing on this problem is the phase shift. And this is the easiest one to graph.
How do you know if it changes?
All right, because here's my original graph. The amplitude, didn't I go up 1? So it is 1, it stayed the same. Period. My first graph was 2 pi, and this one's 2 pi, didn't change. There wasn't a location change anyway. So this is the only one that's changing. All right, so here we go. Phase shift, guys, all it means is you're going to shift it over. Matthew, it's like taking it and just sliding it over to pi is what it's like. Either sliding it left or sliding it right. This says slide it over to positive pi. So instead of starting it at 0, take the whole thing, just slide it over. So I'm going to need a little more room right here. So now in your color, because it's your last graph, you draw the same exact thing you had. It's just you slide it over now and start it at pi instead of starting it at 0. So a phase shift is just when you shift it over. This is number 3, not number 2. Yep, should have said that. Phase shift is just when you shift it left or right. I think that's the easiest one for me to remember. All right, any question on 3 before we go to 1? Oh, sorry, before we go backwards and go to number 2. All right, let's go to number 2 now. All right, so we have a new parent graph we have to draw on this one. Cosine is different, guys. This time it starts at 1. All right, put the points. Don't draw a shape through it yet. Just put your points. This one starts up at 1, then goes to 0, then down -1, back to 0, and up 1. Now, it is not going to be a V. When you graph this one, guys, it's curved. I like to think of it, it looks like handlebars on a bicycle. Yeah, I'm not happy with that drawing at all.
Do we need to draw?
Yeah, you need to draw. Handlebars on a bicycle. Think of it that way. It's curved. Yeah. Beach cruiser. All right, now, don't draw what I'm about to draw, but Matthew, if I kept going this way with my line, y'all notice it's the same thing as the sine wave, it's just been shifted. So, all right. All right, so that is our cosine graph. So now we got to write our 4 answers down for our new problem. All right, let's do that. So I got amplitude. What's our amplitude on number 2? 1. Gotcha. Period. 2 pi over 2. So put it in your calculator. No, put it in your calculator. Just pi. All right. Is there a phase shift? Why not? Good. Is there a location change? All right, so on this problem, what is the only thing we have to change for our new graph? Amplitude was already 1 because we were already going up 1. The only thing we have to change is the period. All right, this is where it gets a little tricky. Let me get me a pretty color here. We'll go with this. All right, so does everybody agree the length of our first line was 2 pi? Well, now they're saying, Matthew, the length can only be 1 pi. 1 pi from here to here is 2 spaces. It's So we've got to shrink it from 4 spaces to 2 spaces. Does that make sense? So watch how I'm going to do that. I'm still going to start it here, but instead of going over 1 and 0, I'm going to go half the distance. And this way, I should be able to fit it in. So now look, I've got the same shape, but I just squeezed it into 1 pi instead of 2 pi. Think about that, see if y'all got a question for me.
Wait, okay, so explain that again.
All right, our first line we had on this one, Leanna, for cosine, the period was from here to here, 2 pi. It was 1, 2, 3, oh, that was a line there. 1, 2, 3, 4. It was 4 spaces long. Does that make sense? Now they're saying, look, it can only be pi. So it can only be 2 spaces long. So I had to take this shape we had and I had to squeeze it.
So the end of it can only
I had
go
to
to
squeeze this in. This end stayed. I took this in and I squeezed it to here.
The end of it can only go to pi.
Yes. Anybody else got a question? That was a good question. That's the hardest one for me to explain, and that's the hardest one for kids to do. The other 3 are never a problem. Question before we go to 4. All right, let's go to 4. There's 3. All right, here's 4. All right, number 4. Which one do we have to graph on 4? Cosine or sine? Cosine. So let's graph cosine. Go back and look if you need to at number 2. I know it starts here, goes there. Remember, it's just handlebars on a bicycle. Make sure you curve it like that. Cosine is handlebars on a bicycle. Give y'all a chance to draw that. Mm-hmm. And go back to 0 and go up 1. Yep. Just like I got it on the board. All right, go ahead and find your 4 answers now for your new problem on number 4. All right, what's our amplitude going to be? Amplitude 3, all right, period. 2 pi over 1, so it's 2 pi. There's not a phase shift because there's no parentheses. Yeah, hey, it's got a down 1 on the location change. This is our first time we're doing a location change. Down 1. All right, so this is also the first problem we've had where they're changing more than 1 answer. Now look, at the beginning of this problem, our first graph cosine was 2 pi. This one's 2 pi. We don't have to worry about that. It's staying the same. The only thing we have to change is the amplitude and the location change. All right, so when you have more than 1 thing that changes, you have to start in the back and work your way to the front. So we're going to work right to left. So we're going to do the location change first. All right, location change is down 1. Matthew, it's like grabbing this line and sliding everything down 1. First thing I want y'all to do in your color, make a dotted line down 1. That's going to be our new x-axis. Make a dotted line down 1 all the way across your graph so you can see it, because they want us to move everything down 1. All right, now in your pencil, go back and let's move all these points down 1. That point, that point, that point, that point, and whoa, hang on, I messed up, sorry. Got ahead of myself. So that one moves down 1 to there, that one moves down 1 to there. Now draw the same exact shape. So look at what I've done. I have moved everything down 1 space. That's your location change. If it said up 4, we would move the whole graph up 4. Points, dotted line, everything. Anybody have a question on the location change? Yeah, I would just draw my dotted line down forward, put everything on the dotted line. All right, so now we got to do the amplitude. Now, what did y'all learn a minute ago about the amplitude? The points that are on the x-axis stay on the x-axis. So these 2 right here are going to stay. Go ahead and draw with your color over those. On on our new x-axis, which is our dotted line. So I colored there, I colored there. All right, now what does amplitude mean we got to do? Remember, amplitude just times it by 3. So y'all see where I went up 1, times it by 3, now go up 3. 1, 2, 3. Hey, it's from the dotted line, remember. That's where you're counting from, the dotted line. So Matthew, this one I went down once, now I go down 1, 2, 3. This one was up 1, so it's 1, 2, 3. So now, make your shape. Not happy with that color. Let's get another one. That is your last graph. That should be the only one drawn into color on number 4.
So you bring those up 3 and then the middle point down.
Excellent. What you're doing is multiplying by 3, Leanna. So this spot that went down 1, you now go down 3. This spot that went up 1, you now go up 3.
But the ones that are on the dotted line stay.
Yeah, and here's why. Because if they're on the dotted line, they're at 0, and 3 times 0 is 0. So it's not going to move. So think of it as multiplying every point by 3.